Welcome to this short presentation and demo about ICPU, a unique tool that can show where your application programs burn the most CPU in CICS. ICPU is easy and intuitive to use also for application programmers. You can even run multiple sampling tasks in parallel with no additional overhead. ICPU also has some unique features not found in other tools that are much more expensive and need specialist manpower to figure out the results. The best feature of ICPU is probably that it is possible to run it in your production environment at a minimal overhead measured to be not more than 5% and find out what the most executed code sequences in all of your applications are and concentrate on improving those. Recently, we added a new feature where you can even catch automatically those runaway tasks that use an exceptionally high amount of CPU and point to the exact code sequence, a task almost impossible to achieve with other tools. What does ICPU do? ICPU has a periodic look at CICS, its control blocks, the currently running program, and the PSW in order to record where in an application program the CPU was used. For this purpose, a program is logically divided into numbered parts that are used to count how many times during the sample period ICPU found the CPU to be in a specific part of that program. This allows ICPU to point to the code that is executed the most and enables a programmer to analyze and then improve the code in order to lower CPU usage, therefore getting more work done by an expensive resource, namely the CPU, and saving money in the process. Let's show you how easy it is to use ICPU. We type the initial transaction ID ICPU, hit enter, and receive this start screen. Here it is possible to define new sampling tasks, either a normal one or exception inspection. You can also inquire about past sampling tasks that have finished, or observe currently running sampling tasks and see the results change online. It is possible to terminate the sampling task or delete tasks whose results are obsolete. Changing the default values that ICPU uses for its sampling activities is done here as well. And ICPU is protected by a password, which can be set through the appropriate function in this screen. We select the option S and go to the Start Inspection screen. All screens support the PF1 key in order to get the corresponding help screen. By pressing Enter, you get the more help screens. PF3 will return you to the Start Inspection screen. You can choose any unique 8-byte ID for your inspection, or use a prefix with a plus sign which automatically allocates the next free ID based on the prefix and the next free running number for the plus sign. Let's use test plus. An important feature is that you can limit the sampling to be for a certain program, task, terminal, or user ID, or any combination of those parameters. A feature that is very helpful for your application programmers that want to test their own programs only. Hitting enter will start a sampling task. ICPU will give you a message saying so. You can then go to the Inquire inspection, PF3, hit enter twice, and if you hit enter, ICPU will bring you the first active sampling task and show you the results. We have a second screen in the same CICS where we'll start now the demo transaction by typing ICPD-CBAS, which will invoke a COBOL demo program, which is also shipped with ICPU, to execute a loop of assign commands. Hit enter, you see it finished very quickly. And now we swap back to the ICPU Inquire screen, hit enter, and we see that the counters have changed. If you go with the cursor to the first program line here and hit enter, we will get the results in more detail. On the top, you will get general information about the program that was found to be active during the sampling task. Things like from which load lib the program was loaded or when it was last link edited. More interesting, however, is the split of the CPU usage by application, CICS, and other services. This split allows you to exactly understand where the most CPU was used and which CICS commands were employed by the program. Here you can see XXCS as sign. If you put your cursor on under the first slice of the program and hit enter, the slice, you remember those logically divided parts of the load module, then you will get to the source code that will show you exactly what COBOL and or CICS command was used. Once you have found the place where the CPU is used, you only have to analyze this part of the program and decide how to improve it. It is also possible to start an exception inspection without termination, the regular ones, of course. Let's do that. And we use EXCP plus, exactly the same way as in the normal sampling start screen. We hit enter. And again, ICPU is telling you that the inspection was started. Those parameters here below are taken as defaults from the customization screen and mean that a certain task must use within the indicated check interval, in this case 60 seconds, at least the percentages of CPU, in this case also 60, in order to be written out as an exception record. The exceptions limit number allows us to decide how many exception records we are prepared to tolerate for a given exception sampling period. This is a protection feature in order not to have too many records that might be triggered in certain high CPU usage situations. Now again, we go to the second screen in the CICS, and now we use the demo program ICPD BSC. This now will trigger the program to do loops in get main free mains. Made a mistake. As you can see, again, the help screen works. ICPD CBSC. See, the program has finished. We go back to the second screen, hit enter, and we can see that again the demo program has shown up. We use it by putting the cursor under the program and we get a detailed offset. We hit enter, and here we can see that the Freeman was caught to be the most expensive command. With PF7 and PF8 you can scroll through the program. If you lost your footing, you use PF9 to reposition you in the exact command that was found to be the most CPU intensive command. To sum it up, ICPU is a sophisticated, easy to use tool that can help you save expensive CPU cycles in your CICS systems. As you can see, MIPS is very, very expensive. If you need more information or want to test drive ICPU, then please do contact us. Below are our details. Thank you very much for your time and attention. Welcome to this short presentation and demo about ICPU, a unique tool that can show where it is to use also for application programmers. You can even run multiple sampling tasks in parallel with no additional overhead. ICPU also has some unique features